Okay, so in this lesson, we're going to learn how to add and subtract rational expressions. So we've multiplied, divide, now we're going to add and subtract. So adding and subtracting rational expressions is related to adding and subtracting fractions. So you're first going to identify the LCD, which stands for the least common denominator. So you're first finding that. Once you know that, you're going to multiply the numerator and denominator of one or both fractions by the value needed to rewrite the fraction with their LCD. Then you're going to add the two numerators, because when you add fractions, you only add the numerators, and then you keep your denominators the same. And then at the very end, you need to simplify if needed. So, first thing we need to do is find the LCD. Now, if you, this is how I like to do it. If you want to do it a different way, that's fine. So what I like to do is use factor tree on the denominator if possible, but notice I can't on the 3 or the 7. So to find an LCD, you're always bringing down your prime numbers. So you always bring down the first denominator, so that's a 3, because I wasn't able to use factor tree. And then notice I do not already have a 7, so I also need to bring that down. So my LCD will be 21. So looking at my first fraction, I need to multiply my denominator by a 7 to get 21, and then I have to do the same thing to the numerator. So I'm going to get 14 on top over 21. And then I have to multiply the denominator of the second fraction by a 3. So I have to do the same thing on top. So that's going to be minus 12 over 21. And then again, we're only combining the numerators when you add and subtract fractions. So 14 minus 12 is 2 over 21. And then at the end, we simplify if possible, but that is reduced. So we'll leave it as 2 over 21. All right, next example. We have to find the LCD, but before we find the LCD, I want you to use factor tree if it's just one number. So that's a 2 times a 3, and then that's 2 times 4, 2 times 2. So get it down to all prime numbers. You always bring down everything from the first denominator. So I'm bringing a 2 and a 3. Looking at my second denominator, I already have a 2 in the LCD, so I'm going to mark out that first 2, but I don't have 2 more, so I need to bring 2 more down. And then I'm multiplying all of these together to get the LCD. So 2 times 3 is 6, times 2 is 12, times 2 is 24. So the LCD is 24 here. So I'm going to have to multiply 6 times 4 to get 24. So I do the same thing to the numerator. So that'll be 4 over 24. My second fraction, I need to multiply it by 3 on top and bottom. So that would be plus 9 over 24. And then at the end, once your denominators are the same, you're just adding your numerators, and that would be 13 over 24. We can't reduce it, so that's our final answer. So this is how I like to find a LCD. If you have another way of finding that least common denominator, feel free to do that. Okay, this is just how I do it. So if there's one term, I just like to use factor tree to get it to all prime numbers, bring everything down from the first denominator, and then if whatever you don't have in the second denominator, you need to also bring down to find the least common denominator. Okay, so adding rational expressions are very similar to you just adding and subtracting fractions, which we just did on part A and B. So to add or subtract rational expressions, you're first going to factor your denominators. You're going to find your LCD. And then we're going to multiply the numerator denominator by whatever we need to in order to get the LCD in the denominator. We're going to then just add the numerators, and then at the very end, we're going to factor the numerator and divide out common factors if needed. Also, notice it says record any excluded values. Okay, so looking at this first one, we have to get a common denominator. So notice I can't factor 2x. So to find the LCD, I always bring everything down from the first denominator. So I'm going to bring it down. I can't factor it. Notice my second denominator, I can't factor that as well. So remember, we've discussed canceling out terms. They have to look exactly the same if you're adding and subtracting. Notice I do not have an x minus 4, so I have to bring that whole thing down to form my LCD. Okay, so I can't just bring down the minus 4 because I already have an x. If it's a binomial, it has to look exactly like that. in order to not bring it down. Okay, so my first fraction, I'm going to have to multiply this denominator by an x minus 4. And then I'll have to also do that on top. And then my second one, I need to multiply by 2x, and I have to do the same thing on top. So I'm going to go ahead and I have to go ahead and distribute these two on top. So 2x times x is, or x times x is x squared. X times 3 is 3x. Negative 4 times x is a negative 4x. And negative 4 times 3 is a negative 12. Over, I don't want to I never want to multiply these together, my denominators, because I want to keep it factored. The reason I want to multiply by numerators is because I'm having to add it with another numerator. So I'm going to put a plus. Denominator, I have a 2x now, and then an x minus 4. So I need to multiply the numerators. That's going to give me a 6x. Okay, so once I've done that, I'm going to add my numerators. So notice I have an x squared, but I don't have another one, so I'm going to write x squared. I have a 3x minus 4x, which is a negative 1x, but I also have to add the 6x, so that's going to make 5x. So I combined all of those, and then I have a minus 12. Again, do not ever multiply your terms in the denominator because we want to keep it factored. The reason we're doing it on the top is because we're having to add it to another numerator. Okay, so at the very end, you need to check and see see if your numerator can be factored. So this would be sum and product since it's a trinomial. Sum would be 5, product would be negative 12. So that would be negative 1 and 12. That doesn't add to 5. Negative 2 and 6. That doesn't add to 5. Negative 3 and 4 doesn't add to 5. So we're not able to factor it. So this would be my final answer. Sometimes you can keep going, sometimes you can't. Now, make sure that you look to see what your x values cannot equal. So I would suggest looking at your LCD to determine that. So this piece, if we set it equal to 0, would be a 0. We can't have a 0. This piece, if we set it equal to 0, that would be a 4. So our x values cannot be 0 or 4. Okay, let's try another example. So notice my denominators are not the same, so in order to add them, I must find an LCD. So first thing I have to do is look at my denominators and see if I can factor them. Notice this here is 2 terms, and it's difference of 2 perfect squares. So when I factor it, it is x plus 1, x minus 1. So that means the same thing. So remember, to find your LCD, you always bring everything down from the first denominator, factored. And then looking at your second denominator, notice I cannot factor it, but notice there's already an x plus 1 in the denominator, or in the LCD. So I do not need to bring it down because we're trying to find the least common denominator. So if it's already formed in the LCD, you do not write it again. So my LCD here is x plus 1, x minus 1. Notice my first fraction already has my LCD, so I don't need to do anything to the numerator or the denominator. Bring your plus sign down. Second denominator, notice only has the x plus 1, so I need to multiply it by the x minus 1 on top and on bottom. So I'm going to have to distribute. It's going to be x squared minus x, and then remember, do not distribute the denominators because we want to keep them factored. The reason we're having to distribute the numerators is because I'm having to combine the 2 numerators together. We don't combine denominators when we add or subtract. Okay, so combining like terms, notice in top I have an x squared. And then I can combine the x's, which would make 4x. And then I just have that plus 3 there. So looking at my numerator, notice I have a trinomial, so that means I need to use sum and product to see if I can continue with factoring it. So sum would be 4, product would be 3. So 1 times 3 multiplies a 3, adds to 4, so we can factor the numerator. X plus 1, x plus 3. Okay, so notice that the x plus 1's cancel out because there's one on top and bottom. So I'm going to have left x plus 3 and x minus 1. So when you're writing your excluded value, you always want to look at either your LCD or what you have in the denominator before you cancel anything out, which is your LCD. So my x's cannot equal -1 or +1. Okay, so in adding and subtracting rational expressions, you are having to find a least common denominator before you can add or subtract those numerators. Okay, let's look at the... All right, we're going to now just look at subtracting. Okay, so same exact thing as adding, except you subtract. So we're going to factor the denominators, find the LCD, multiply the numerator denominator by whatever is missing in the LCD, and then we're subtracting the numerator. Subtracting can get tricky and lots of mistakes can happen. You need to remember to distribute the negative sign since you're subtracting if the second numerator has more than one term. So that's a key there. Star it, underline it, highlight it so you don't forget to do that. Then you're going to factor numerator and divide out any common factors and record any excluded values. Okay, so we have to get a common denominator. First thing, we have to factor the denominators. Notice this first denominator has a 2 in common, so that would leave me with x minus 3. Notice the second one has a 4 in common. That would leave me with an x plus 2. Okay, so we need to start forming our LCD. So remember, everything from the first one gets brought down. So I'm bringing a 2 and I'm bringing an x minus 3. Okay, so then notice I have an x plus 2 here. I don't already have one. I need to bring it down. Now, notice this number by itself in the front is a 4, which is 2 times 2. I already have 1 2. So I don't need to bring that, but I need to bring another one down, which will then give me a 4 in the front, then x minus 3, x plus 2. Okay, so there's my LCD. So looking at my first denominator, I have a 2, I have an x minus 3, so I'm missing this piece of it. So I need to multiply by 2 and x plus 2. Okay, so I would suggest when you're multiplying the numerators, you need to go ahead and multiply those regular numbers without a variable in the front, which would give you 6, and then distribute it. So I'll just go ahead and just write it. So 6, and then I would have an x plus 2. My denominator, I multiply those to get the 4, and then I'm just leaving it as x plus 2, x minus 3. Okay, so I'm bringing down my subtraction sign. Looking at the second denominator, notice I have a 4, which is these two pieces, and I have an x plus 2. So I'm missing x minus 3. And I'm just going to go ahead and just write it there. So I now in the denominator have 4, x plus 2, and x minus 3. Okay, so remember I told you up at the top when you're subtracting, you can make lots of mistakes because of the subtraction sign here. So what I would suggest is go ahead and just rewrite your numerators all as 1. So 6x plus 2 minus 5x minus 3. The reason I'm telling you that is so that way you can visually see that when you distribute the second one, you're going to have to distribute -5 with it. So when I distribute, I get 6x plus 12. Then, again, this is -5 minus 5x, and then that's a -5 times a -3, which is a positive 15. So again, this is a common mistake right here. So don't forget to distribute that subtraction sign with that number when you distribute. Remember, never multiply your denominators because you want to keep it factored. Okay, so we're going to combine like terms in the numerator, so that would just be an x, because 6x minus 5x is x, and then 12 plus 15 is 27. Checking your numerator at the end, notice I'm not able to factor x plus 27, so now I need to look at my excluded values. So again, I would just suggest looking at your LCD, or in this case, it's still the LCD in the denominator because we didn't cancel anything. So nothing would cause this piece of it to be 0, but -2 would cause this one, and then +3 on that one. Okay, so let's look at the last one. So remember, the first step that you have to do is factor your denominators. So that's what you're always doing at the very beginning, so that way you can find your LCD. So notice they have an x in common. That leaves me with x plus 6. Looking at my next one, notice it's a trinomial. So on a trinomial, I need to use sum and product. So sum is 12, product is 36. So that would be 6 and 6. Okay, so to find my LCD, I always bring everything down from the first one that's factored. The second one, I'm looking to see what I already have and what I don't have. So notice I already have one x plus 6, but I don't have the other x plus 6. I can't just bring down the plus 6 because remember, x plus 6 goes together. So I have to bring another one down there. All right, so looking at my first denominator, notice I have an x and an x plus 6, so I'm missing an x plus 6. Whatever I do to the denominator, I have to do the same thing to the numerator. So notice I'm going to go ahead and distribute these two, so that's going to give me 3x squared plus 18x. And then my denominator, remember, you're not going to multiply those together, you're just going to keep them as the LCD. Okay, so then bring your subtraction sign down. Looking at your second denominator, notice we have the two x plus 6's, but we're missing an x. So I need to multiply that on top and bottom. So when I distribute that, that's 2x squared, and then plus 12x. Okay, so I would suggest with the subtraction one that when you combine, before you start combining the two numerators, I would go ahead and put them all together on the top, and remember that you're going to have to distribute. Since this is a -1 here, you'll have to distribute that on top. So remember, subtraction, there's a common mistake, and it's this subtraction sign right there. So you're going to have to distribute the -1 there. So that would be 3x squared plus 18x minus 2x squared. And then don't forget to distribute it to the 12x. So minus 12x. And then your LCD. So combining your like terms in the numerator, the x squareds we can combine, which would just be a 1x squared. We can also combine the 18x minus 12x, which would give you 6x, and then just writing your LCD. Okay, so looking at the numerator, you always want to check and see if you can factor it. Notice they have a greatest common factor of an x. That would leave you with x plus 6. All right, so if you notice here, we're going to be able to cancel a few things out. Notice the x's will cancel, the x's in the very front by themselves. And then also notice the x plus 6 will cancel. So remember, we've talked about any term divided by itself is 1, so I have a 1 on top, and then an x plus 6. Now, whenever you're looking at your excluded values, you need to be looking at your LCD before you start canceling things. So this would be a 0, so x cannot equal 0. This piece would be -6. And then same exact thing on that one. So x cannot be 0 or x cannot equal -6. Okay, this is adding and subtracting rational expressions. You have to find a least common denominator, and then you're having to adjust each fraction in order to get your denominator to that LCD, and then you're able to combine the numerators. Make sure at the end, your numerator, see if you can factor it, because if you can factor it, sometimes you're able to cancel terms out. If you have any questions on adding and subtracting fractions, please let me know.